Year 11 Maths Advanced. Very exciting. As you can see, we're just on the OneNote right now. If you go into Content Library Miscellaneous, you'll find a copy of the syllabus, and I'll also put the Year 11 handbook that I should have just handed out to you in here, where you'll find the scope and sequence and assessment schedule. The textbook, yeah, the one here is just the whole textbook. Yes, Campbell, you need to not have to download this every single class. If we go into topic 1, algebraic techniques, you'll find just the chapter 1 of the textbook, and also the answers are down the bottom. And if we actually look at exercise 1A, actually I'm going to change this paper. How do I do that? View, paper style. Oh, that looks nice. It's nice. It's different. It's unusual. Maybe that's slightly blue. Slightly easy to see. I don't think so. No colour. Let's have a look at the actual textbook textbook chapter. We're looking at exercise 1A, so let's open her up. Yada yada. Now, exercise 1A. A pronumeral. You know all this. You know what a pronumeral is. You know what a variable is. You may not be used to using that terminology. Get used to it. Deal with it. Suck it up. Like and unlike terms, if I still have to explain to you that you can't put x squareds together with x's when you're adding or subtracting, you need to get better. And I'm not gonna like go through example 1. You know how to put like and unlike terms together. You know how to add and subtract with letters and numbers. Multiplying and dividing, you also know how to do this. So for example, 3y times negative 6y. I dislike how Cambridge uses these brackets, but I kind of guess why they do. So you don't think you're subtracting the 6y, it's negative 6y. You multiply the numbers, put your letters together, negative 18y squared. If you're dividing, it might help you to actually write this vertically and then simplify, like cancel out. The y's cancelled out, 10 divided by 5 is 2. It was nice and easy. So, index laws. These are the standard laws you need to know. They're important. They're seriously important. Actually, Command Shift 4, I think, yes. I'm going to put these. Let's see if I know how to do this. Exercise 1A. And if I paste that in, is that going to work? That decidedly does not. Okay, so these index laws, maybe if I try Command Control Shift. It's a satisfying noise. I hope you guys can hear that noise. And then can change. Yes, there we go. Those index laws, most of them you guys have automatically. You know that when you've got two things multiplied together, you add the indices. If you're dividing, you subtract the indices. If you've got a bracket, you multiply the indices. The thing outside the brackets applies to both things inside the brackets, and same diff with fractions. So let's have a look at the examples they've set for these ones. We'll actually go through these. Command V. Okay. Let's have a look. So that first one, we've got 3x to the 4 times 4x to the 3. Oh, why is this not letting me maneuver it so easily? Draw. This is the first time I've done this, by the way. I've got it kind of screencasting to my iPad or something. So let's have a look at example A. I like blue. 3x to the 4 times 4x cubed. Well, let's deal with the numbers first. 3 times 4. Those are the big numbers out the front, by the way, not the powers. I wish they hadn't chosen the same numbers for the powers. 3 times 4, you guessed it, it's 12. And then we've got x, and the x to the 4 is multiplied by x to the 3. So we've got 4 plus 3, and that gives us 12x to the 7. Woo! Okay. Now let's look at example B. We've got, I'm going to actually write this out again vertically. I just like to have it vertically. So we've got 20x to the 7, y to the 3. Sorry about the music in the background. It's hot as 100. I have to have it on. 4x to the 5, y to the 3, 5y cubed. Okay, now let's deal with the numbers first. We've got 20, we've got 4. Simplify that. How many 4s go into 20? We've got 5. And how many 4s go into 4? We've got 1. I mean, you could write that out. Yeah, I'll write that out. Now let's actually have a look at our x to the 7 and x to the 5. We're dividing. The fraction means we're dividing. So we're going to subtract. 7 minus 5 is 2. Is the bigger one on the top or the bottom? It's on the top. So we've got x and then we've got our 2. And now let's have a look at our y cubed. Now, what's 3 minus 3? It's 0. So technically we could do a y to the 0. Why would we even bother get it? Why would we? So overall we've got our 5x squared. Y to the 0. We're not going to bother writing it because it's just 1. Anything to the power 0 is 1. Anything divided by itself, because to the 0 means it's divided by itself. It's just 1. All we ended up with on the bottom was just that 1. Anything divided by 1. Like, do we need to write that the whole 5x squared is divided by 1? No, we're going to write it. We're going to leave it as it is. Okay, now let's have a look at example C. Got some brackets. Nice. 3a to the 4, all raised to the 3. That means every single thing inside that bracket is raised to the 3. So the 3 in front is raised to the 3. The a to the 4 is also raised to the 3. And we write a little times. Now, you may be wondering, Miss Crayons, why didn't you write something times 3 with that big 3? Well, that was just 1 times 3 because it was 3 to the 1 inside the brackets. If there's nothing there, it's to the 1. You don't need to, you shouldn't need to bother writing that out. 12, and what is 3 to the 3? 27, a to the 12. Obviously, you're not going to write your solutions horizontally like I am. You're going to write them nicely and vertically with a new line of working out on each line. But I just kind of want to be able to see the questions when I do this. Let's go into D. Let's have a look. We've got negative x squared to the 3 times 2xy all to the 4. Now, this is a really interesting one. So I'm actually going to write this out again as negative 1 x squared to the 3. Why is my pen doing that? That's really annoying. Oh, I'll figure that out later. Times 2xy to the 4. Which means we've got negative 1 to the 3, x to the 2 to the 3 times 2 to the 4, x to the 4, y to the 4. You may be wondering why I didn't put brackets on the right. I didn't need to. There was nothing special. What's negative 1 raised to the power 3? That's negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is positive 1. And that times negative 1 is negative 1. So we've got negative 1. X to the 2 raised to the 3. Don't forget that's x to the 2 times 3. And then I've got my 2 to the 4, x to the 4, y to the 4. And that gives me negative. Do I need to write negative 1 or can I just put a negative out the front? I'm just going to put the negative out the front. X to the 6, 2 to the 4 is 16. X to the 4, y to the 4. Let's scroll a little bit. Now, I do have some terms that I can... Oh, no, I want to change my highlighter, thank you. I've got x to the 6 here, but I've also got x to the 4 here. I'm going to put them together. They're multiplied. There's no brackets involved, no fractions. They're multiplied. So I add the indices. 6 plus 4 is 10. So I got negative x to the 10 times 16y to the 4. I really just want to put that 16 out the front. We just like numbers out the front. It means I don't have to keep writing that times. Negative 16 x to the 10 y to the 4. And we're done. And you could have probably done that in 2 steps of working out. You didn't need to write all that. Now let's... Tones and I. Good on them. Sorry, I just 100. Let's have a look at question E. Now, I'm going to write this out. We're not going to be able to see it. 2x over 3y all to the 4. I can't scroll on the iPad. There we go. So I've got 2x over 3y all to the 4. Which means we could break this up and we've got 2x to the 4 over 3y to the 4, because the bracket applies to both top and bottom. Which means, and don't forget, everything inside the brackets is raised to the 4. So we've got 2 to the 4, x to the 4, over 3 to the 4, y to the 4. Now let's deal with the numbers. We don't like numbers like this unless they specifically say leave it in index form. Not that you get marked down unless they specifically said that. 2 to the 4 is 16. X to the 4 over 3 to the 4 is 27 times 81. Y to the 4. Do you not know your 3 times tables like that? That's the whole of that example. And you know what? That's all you need to know for exercise 1A. If we go back and have a look at those questions, like you can group like terms. You can do this. -2 plus 3 plus 4 and chuck an A after it. Negative x plus x, well, they cancel that. That's nice. These ones multiply the numbers and then deal with the letters. These ones, oh my gosh, this is the easiest exercise. This must make you feel really good about yourself, which is why we're going on to 1B in the same lesson. Thanks very much. Ooh, how do I turn this off?